the last video, we will add the lines of code to our doc strings in order to create those three functions that we need in order to compute all elementary row operations. Before we do that, though, let's step through an IPO chart that I created for the first elementary row operation, just so you can see another one of these. These are not bad to do if you just really have no clue the order that you're going to do things and whatnot. I know this one's pretty straightforward, but I like to give you guys as many of these as you can, especially on the easier ones, so that you can utilize those and sort of look at them and say, okay, I get what we're trying to do here. So if you were to produce an IPO chart, so you got to have your little start and your little end, and then anytime you put an input or an output, you put the little this symbol. You have the little square for any kind of process, and then maybe I should probably put another output down here where we return B, but I didn't do that because B is pretty straightforward. That's the only thing that we're going to send back out of this function. So the things that come in, and the other thing is you probably want to have 3 of these for each one of the inputs, but again, I'm sort of shorthanding this, if you will. So I've got A, which is a matrix, and that's the thing that we want to do the operation to. I have the row, which is a 0 index row, so it's the index of a 0 index row. In other words, if it's the first row, then I want to pass in 0. If it's the second row, I want to pass in 1. So I'm just sort of being honest here about what we want to pass into this function. We could change that if we wanted to. I just didn't think that we needed to right now, but thinking back, maybe we do want to go back and it is possible that you could think about saying, okay, well, in linear algebra, when you really think about row 1, you're really thinking about the first row, not the second one. So it might be more intelligent if I design this thing another way. I could leave that as an exercise for you guys. But for now, I'm just sort of saying that you tell me the row by sending in the 0 index number that's associated with that row. And then you get C as the constant. That's what we want to multiply the row by. So every single element in the row, just like we did in the math just last video. And then, so if once we have this input, I claim that we can just use this information in order to do everything that we need to do for this one elementary row operation. So if M is equal to the number of rows of A, we can find out what that is just by owning A. Like when A comes in, we can do a shape, right? So I can do that using the NumPy method shape, and that will tell me M and N. And then we'll pass that down and say, okay, well, now I need to formulate this E, this matrix E that we're going to multiply here at the end. And I'm going to start off, if you remember, we said we're going to start off with the identity, and we're going to just change one of the diagonals to be whatever we want to multiply by. So this is the identity. That's what we start off E as. And then you go in and you go to the row, comma, row, right? So if I'm at 0, if I want to multiply row 0 in A, then I got to change this to 0, comma, 0. If I want to go the second row or the 1th row, if you will, then that would be a 1, 1, and we change that 1 to be a C, and so on and so forth. So whatever you want to change, whatever you want the row that you want to multiply, it's got to be in here along the diagonal. And then we'll just multiply them and then return B. All right, with all that being said, let's go ahead and get started on our code. So I'll put all that business up and we can start. So I got F9. So I hit F9 here just to get NumPy in, and then you got the doc strings. You should have had those doc strings available to you already. We'll come down here. We will program exactly what we talked about here in. Just put it up. So the first thing that we want to do, if you remember, was just bring all that information in, and so that's the A, the row, and the C, and to sort of describe all that information in the doc string. And then the next thing we want to do is simply just say, all right, give me M and N. So M being the number of rows, just like we did in linear algebra, and then A dot shape. It is not a method, it's actually an attribute. I apologize, I think I said method earlier. Shape is an attribute. So it knows for the object A dot shape, which gives you the number of whatever the dimensions are. So in this case, rows and columns. And then we're just going to say E is equal to np dot I. We already talked about this one. I'm just going to pass in M, so that'll be an M by M matrix. And then I'm going to go to row, comma, row, and we're going to change that to C. And that's a pretty straightforward thing. And then we'll let, well, let's do one thing real quick. Let's make this thing called B, and we're going to do A dot copy. So we're setting that equal to B. I believe A dot copy will work. We'll find out here in a second. And then we'll do A. And I'm not sure if you understand why I'm doing that. What I want to do is to make a not an alias, but a clone. So I want to make sure that this thing is sort of separated from, like if I pass in something into ER01, I don't want it to sort of change other things as well. So np dot matrix multiply. And we will multiply E times A, and then I'm not setting equal to A, I apologize, we're going to B. And so B is equal to E times A, and then we'll just return B. So let's find out. And the way that I'm going to do that is just use the code that's in the docstring. So it's pretty nice that someone did this for you. That gave you some sort of a test thing to do. Shift tab. You just got to bring it over and put it in the right sort of place, right? So if you move it all the way over there, it doesn't look right. You know, all Python, all Spider, I should say, not Python, but Spider does is it copies the number of, so I had to get rid of those two tabs over in there. All right, so let's run it, highlight the entire thing and run it. And hopefully we get the same numbers that were down there, and we did, right? So I got the 1, 2, 3, 12, 15, and you could do a bunch of things or try a bunch of different things and try to break it. That's really what you're doing when you're validating the fact that this thing works, is you want to try to break this thing. And if it doesn't work, then it doesn't work, and you got to figure it out, whatever your bugs are. All right, so that's ER01, and then we just simply, there's like 4, 5, 6, maybe 6 lines of code in there. I think this one's extra. I don't know if this wouldn't work otherwise, but I'm just trying to make sure that I want to clone there and not an alias. And so if you don't know, just do the little copy. Let's go. I'm gonna grab these first 3 lines of code because I believe that ER02 needs exactly those first 3 lines of code. So here what we want to do is simply just exchange rows, right? So yeah, I think this one was the one that was the row exchange. So if we start off with the identity, there's this neat little thing that Python can do, and I know we've done this in the past. So row 1, comma E of row 2, right? So remember, I'm passing in a matrix, and I want to exchange these 2 rows, whatever they are. They're not going to be row 1 and row 2. They're going to be whatever the 0 index number that comes in. So if it's 0 and 1, then you're changing 1 and 2. If it's 0 and 5, then you're changing the first one and the fourth one, right? So it just depends on what these things are here. And if you exchange that, what we want to do then is we want to do E row, let's see, row 2 dot, and we want to copy it, put a comma there, and then E of row 1 dot copy. Again, I'm just on the safe side here. I don't want those to be aliases. I definitely want them to be different than what they were. And so I use the copy command. So what we're doing here is row 1 is row 2, and row 2 is row 1. So it's just flipping those orders. And now we have, I mean, we could have done that with A, right? So, but I want to make sure that this is always matrix multiplication. So at the end of the day, I'm going to say, so we've already done B, so B is equal to np dot matrix multiply, and then I'm going to multiply E times A. So that should be the sort of the last line on all of these, right? Because once I've figured out what E is, exactly what E is going to be, then we need to do that matrix multiplication. All right, so F9, and then let's grab Control C, Control V, over. All right, it says we're exchanging those two. Let's find out what happens. Oh, let me just do this. Yeah, oh, did I not? Oh, I didn't return it. That's the problem. All right, you got to return. It's probably because I didn't do it in my IPO chart. All right, F9, and then we returned it, and hopefully it's the same. 4, 5, 6, 1, 2, 3. Okay, so we're good there. Again, you would want to try to break this thing again. Go through, put different stuff in, put 6x5s and 2x7s and just all sort of different matrices and try to figure out if this thing always works, because that's what you want. You want code that always works regardless of the inputs. All right, so I think this is probably the most difficult. So let's go back to OneNote and maybe even back to the previous one. And so let's think about here. Maybe I didn't cover this exactly how we need to. Sorry. So let's just at least talk about this for a second. So what I want to do is take -4, because that's the sort of the constant that's coming in, and I'm going to multiply that by row 1 and add it to row 2. So what position is this in? This is in position 2, 1. So if I am, and that -4 is the constant. So the -4 is the constant that I want to multiply by. So if I want to, let's go back to the thing. So row 1, so linear combination here, let me move this over a little bit. So row linear combinations, row 2 is equal to row 1 plus C times row 2. So we're exchanging row 2. Right, so we know that's where all of the things have to change. And I'm taking C times row 2. Yeah, I want to change that around. That's really what I want to do. All right, so if you put row 1 in, row 2, let's just see if it works. So let's go to notebook. Let's go with, so if I wanted to multiply row 1 and 2, then I put in 2, 1. So I put this in position 2, 1. So let's do the same thing in, so I'm going to copy the first 3 lines. I can even copy the last line because I know that's actually the last 2 lines. And that's it. And then I need to put our code in here that we needed to change. Okay, so maybe it looked like we did this. We did E row 2, row 1 equal to C. Would that have worked in this example, right? So what you want to do is figure out if it works in an example and then sort of try to generalize it. So let me do this. Let's see, do that, and grab this, and come down here and look at the code. Oop. I can do that. So row 2, let's see, row 2, row 1. If I put that as a -4, would it have worked? We would have then substituted in row 2. Yeah, I think it would have. So I think that would have worked. So let's just check it out, see if it, and then try to mess with it. All right, so these 2 lines of code, I'm copying them, I paste them down here, and run the whole thing. And did I get what I expected? make it big. So A is equal to np.array 1, 2, 3. So did I multiply, let's see, by, so 0, 1. So I'm taking row 0 and multiplying, let's see, 3 times row 1, so 3 times 3 plus 7, is that 10? 1, 2, 3, 4, 5, 6. So it should have been 3 times row 1, which would be row 0. So 3 plus 4 is, okay, all right, there we go. All right. So it's 3 times this row plus that row, which is exactly what we got written here. And so 3 times 2 is 6, plus 5 is 11, so that isn't what we're getting. 3 times 3 is 9, plus 6 is 15, which is what we're getting. Okay, and then you can change it. I mean, we can change it to negative that. So what would we want if we were doing elementary row operations? Let's print out this one. So 1 and 4. So I need a negative 4 here again. So do I get a 0? And I do. So that's how we want this thing to work. Okay. I believe this is the code that we need in order to make these things work. We will use these in class when we start looking at the Tableau. I'm going to need you to solve some of that other big problem that's in the Jupyter Notebook about separating, concatenating, and putting things together and creating that Tableau. But if you're able to do all that, then we should have a really successful class, and everybody should be able to do the linear optimization, sort of little small problem, just to understand what linear optimization is doing, and using these elementary row operations in order to get the answers that we want. All right, that's all I got, and I'll see you guys next time.